In this problem, we're asked to solve the quadratic inequality by factoring x squared minus 7x plus 12 less than or equal to 2, and then check by graphing. So let's start by putting this inequality in standard form. So x squared minus 7x, and then I'm going to subtract 2 from both sides, so that's going to leave me with plus 10 is less than or equal to 0. Then I'm going to need to factor the left-hand side. So this is going to factor as the product of two binomials. We're going to have x and x here in the first positions. Some combination probably of 5 and 2, because 10 is 2 times 5, it's positive 10. So these are either both going to be positive or both negative, but since the middle term has a negative coefficient, then both of these are going to be negative. So let's double check. X times x is x squared. We have minus 5x minus 2x is minus 7x. Minus 2 times minus 5 is plus 10. So our left-hand side is factored just the way it needs to be. Now what we're going to do is take each of our linear factors and actually set them equal to 0. So x minus 2 equals 0, or x minus 5 equals 0. That means x equals 2 or x equals 5. If we were only solving an equation, we'd be done. We'd have our answers. We're solving an inequality, so what we need to do next is to create what's called a sign chart. So what I've drawn here is called a sign chart, or at least this is the basics of the sign chart. You might want to pause the video and make sure that you have this template on your page before you continue with the video. Now what I want to do is to identify the sign, S-I-G-N, of each of the linear factors of the factored form of the quadratic inequality inside each of these intervals. So what I did was I took the 2 value and the 5 value, and those are going to divide my real number line, which is this part right here, into 3 regions. A region from negative infinity to 2, a region between 2 and 5, and a region from 5 to infinity. And I want to find the region or regions where this product of these two factors is less than or equal to 0. So I'm going to do that by looking at the sign of each of the factors in those regions and then multiplying those signs to get the sign of the product. I've written some test values, so I'm going to test the value of x equals 0. 0 minus 2 is negative. So at every x value in this region, x minus 2 would be negative. 0 minus 5 is also negative. A negative times a negative is a positive. So the product, x minus 2 times x minus 5, would be positive for every value of x in this region. Going to the in-between region, I'm going to test 4. 4 minus 2 is positive. 4 minus 5 is negative. The product is negative. Testing greater than 5, I'm going to use the number 6. 6 minus 2 is positive. 6 minus 5 is positive. The product then, positive times a positive, is positive. I want the region that makes my product less than or equal to 0. So what I'm looking for is this region right here, including the endpoints, because I have less than or equal to 0, because at 2 and at 5, the product would equal 0. So here's my solution set, just drawn on the real number line. To represent that with inequality notation, that would be x less than or equal to 5 and greater than or equal to 2. So there's my inequality notation. If I want to write this in interval notation, that's going to be the interval from closed bracket 2 up to 5, also with a closed bracket. Now, if we want to test this by graphing using our calculator, then what we're going to do is to graph y1 equals x squared minus 7x plus 10, then y2 equals, actually, let me back that up a little bit. You can do it that way, but it's often better to go right to the original x squared minus 7x plus 12. That's the original up here. And y2 equals 2. If I graph that on the standard window, I'm going to get a graph that looks something like this. There's a quadratic. Here's y equals 2. And if I identify my intersections here, like we've done many, many times, the x value is 2. Here, the x value is 5. And because I want x squared minus 7x plus 12 less than or equal to 2, I want the inputs that give me all of these outputs, the ones below the line y equals 2. So that's going to be the x's between 2 and 5, which confirms what we found using our algebraic method, our factoring method, with our sign chart.